Hello, welcome to Module 5. So in Module 5, we're going to talk about one of the most useful techniques for performing test cases creation. Okay, let me share the screen. Hello, welcome to Module 5. So in this module, we're going to talk about one specific technique that you can use to create effective test cases. It is called input space partitioning. Okay, before we get started, let's do a quick recap of the RIPR model. The RIPR model stands for reach, infects, propagates, and reveals. Okay, the reach means you have a test cases and you want to make the test cases reach the faulty location. So that is one of the technique in input space partitioning that we want to make the test to reach the faulty location. The second one is we have the faulty location. We want that faulty location to infect the program, to make the program in the incorrect internal state. Okay, let me fix this a bit. And when you have the incorrect internal program state, you want it to propagate to the final state of the program. So the final state of the program is where the output can be seen from outside. The users can see those output. And you want those incorrect internal state to propagate out into the final output. And it is intersect with the part that the user actually observe, or he or she is looking at that particular location. And then the fault is revealed to the users or to the developers when you do testing. Okay. So today is one of the techniques called input space partitioning that we want to partition the input domain. So we will use one of the A and T principle called partition to perform this kind of test. And it is a fundamental technique. We're going to talk about the benefit of this technique, how to do input space partitioning, and how do we model the input domain. Okay, so let's get started. First, software testing is the process of finding test input values to check against the software. Okay, so the finding test input is the key of doing testing. How you would find the very effective test inputs, that is the most important thing. So test cases consist of two things. First, test case values, and second, expected results. When you input the test value into the program, you would get the actual result from the program, and then you would compare that with the expected result and see whether they are the same or not. Oh, okay, I think I have the animation here, which is the same. So the testing technique or the testing process is fundamentally about choosing a finite set. Okay, oops. Oh, how can I? Just a moment. Okay, it's about choosing the finite set, which means some limited amount of test case value from the input domain, which means all possible value. Something wrong with my PowerPoint. Just a moment. All possible value of the software being tested. And then when you give the test input, you get the actual result, and then you compare the actual result with the expected result. Okay, so let's talk about the input domains. The input domains are all possible values that the input parameters can have. And this input domain can be infinite, even if you have a small program. Okay, how can the input domain be infinite? For example, if you have a variable string name, this string can have many values starting from an empty string, 1-character string, 2-character string, 3-character string, so on and so on. So the number of strings that the number of characters that you can have in a string is unlimited in theory. And with just this having the name variable or parameter, you can have a very large amount of input domain to be covered. Okay. So testing, it's about choosing the finite set of values from the input domain. So if you have this very large input domain, how can we pick some of them? Let's say 5, 10, 20 to be the test case value, and that is testing. So input parameters can be many things. So in the code, the parameters to a method can become the input parameters. The global variable can also become a parameter. The objects that represent the current state in programming, when you have an object being passed between module, this also a parameter. And we have different type of tests to check these kind of input parameters. So in parameters to the method, you would do unit test. The global variable, you would do unit test. But for the objects that represent the current state, you would do integration test because the objects are being passed between the classes. And the user input that the user put in, something like you have a field that the user will input some value. This will be the input from the users. And that would be done when you do system tests, when you have the full system, and then you ask the user to input something at the user interface. And the input domains can be some other input that you read from a file or from a database or from an API. Okay, so there's a lot of possible input domain parameters that you can get. So let me show you an example of one simple program. So this is a method called getIndexOf. Okay, in the getIndexOf method, we know the specification here. So the specification say return an index of the first occurrence. Okay, return the index of the first occurrence of letter in a string. Otherwise, return -1. So the program will search for the letter inside the string. And if it finds the letter inside the string, it will return the index, which is the location of the first occurrence of that letter in a string. So you start with index -1, and then you loop from 0 to the length of the string. And if the string at that location is the same as the letter, you return the index. Okay. So with this simple program, we're going to use it to generate test cases. So the first thing is we need to start thinking about what is the input domain. So what is the input domain of string? Let's pause the video for a minute, think about it, and then resume. Okay, the input domain of a string, we already talked about it, is pretty large. So you can have an infinity domain for string. For the letter, you have a smaller set of input domain. So let's say if it is an ASCII code character, we can have 256 value for the letter as the input domain. Okay. So what is ISP, or input space partitioning? Input space partitioning try to partition your input domain into smaller chunks. So let's say we have the domain D, and we want to partition them into smaller chunks, which we call blocks. Okay. And let me show you by this picture here. So this whole thing is D, which is the whole input domain of one input parameter to the program. We would have some partitioning criteria to chop them into smaller pieces, and you would get block 1, block 2, and block 3. We need to satisfy two properties here when we do partitioning. First, the blocks that we partition, they must not overlap. And this is a property called disjointness. The second, the blocks must cover the entire domain. So when you got all the blocks and you combine them back together, you should get the whole domain back. You shouldn't miss anything. And this is called completeness. The difference between disjointness and completeness is, for disjointness, you don't want the blocks to have any overlap. Think about intersection. You don't want any intersection between all the blocks. About completeness, you want them to get back the whole thing when you combine them. So this one, think about union. When you put all the blocks together, you should get the original set back. All right. So after finishing this kind of partition, you check for the disjointness and the completeness property. Then you select the representative. You select at least one value from each block. Okay, so let's say from this block, I pick one value. From this block, I pick another value. And from this block, I pick another value. By picking a representative from the block, you can pick any value because each value in the same block is supposed to be equally useful for testing. All right, so you might get different set of representative values depending on which value that you choose from one person to another person, and that's totally fine. The benefit of input space partitioning is as follows. First, it is a pretty easy and simple technique to get started with. So you can apply the ISP into anything without automation and with only little training like today. Okay. Second, it is easy to adjust to get more or fewer tests. And this depends on the number of partitions that you have. So if you have more partitions, you would get more test cases. If you have fewer partitions, then you get fewer test cases. Third, there is no implementation knowledge required. You can just read the spec of the software that you are going to test, and then you can generate the test cases using input space partitioning. You need to know what are the parameters at least, okay? So that's the third benefit. And the last one, it can be applied to several levels of testing. Either it's going to be unit test, it's going to be integration test, or it's going to be the system test. If it is a unit test, you would get the input from the method parameters. Oops, something wrong. If you do integration test, you should get an input from the objects. And when you do system test, the input will be the user level inputs into the program.